All right, so let's talk about some examples. Thank you for your patience. All right. So example 1, okay, is we're going to solve for x and round to the nearest tenth on the following triangle that I'm going to draw. Okay, if necessary. So here is our triangle. There's a triangle. Now, I'm going to give you guys the angle and a side. The side is 5.3. This is a right triangle, and the angle I'm going to give you is over here, and it's 51 degrees. This is triangle P, O, and N. Okay? Or N-O-P, whatever order you want to go in. Okay, as long as the first letter and the last letter are, there they are, and the middle letter is right there. Okay? So, we need to figure out what function uses adjacent and hypotenuse, because we have a angle right here with an adjacent given side, but no hypotenuse. Okay? So, we're going to call the hypotenuse just some variable. Let's call them x. We're lazy, right? Boop. There we go. So, we need to find out, that's the question we need to ask ourselves, right? What function uses adjacent and the hypotenuse? Okay. Now, if we remember SOHCAHTOA or some old hippie, okay, it would be the middle one, right here. Is what we need to look at, because it has an adjacent hypotenuse. We have cosine, all right? So, we're going to take the cosine blue. The cosine of P and set it equal to the adjacent,
that makes more sense.
Yep, over the hypotenuse.
Opposite and hypotenuse. And then you got adjacent.
Yes. Now you're starting to make, yep, good. I'm like to hear the ahas here. All right. So it's going to be 5.3 over x. Plug in also what we know, which is the angle. So now we have the cosine of 51 equals 5.3 over x. Uh-oh. Wait, how are we supposed to calculate that? First of all, don't panic. Just like algebra, we can isolate the variable, can we not? Yeah, we can. We can get x by itself. Multiply x to both sides first. So we get x cosine of 51 equals 5.3. Divide cosine by 51 on both sides. And what you get
Why do we put the 51 right there?
is x, because I will come back to that question. The cosine, we get 5.3 over the cosine of 51. Now, the reason why we put cosine there is that's actually a trigonometric operation. It's kind of like times, division, or power, or to a power 2, square root. It's basically a operation that modifies the number, okay? Which was determined by, essentially speaking, a limit. Or some form of a algebraic proof that was conducted hundreds and hundreds of years ago.
So you can't go past 50.
No, you can go all the way to 100. You can go all the way to 360. The cosine of 360 is, hang on, to remember, 0. Okay? It's 0. Now, you will need a calculator. Now, I'm going to show you this once. Don't do what I did on a math test in college and do the entire test in scientific when they want radians. Not a good move. Now, for right now, I don't care which one you use realistically, but we will probably be dealing with probably decimal for right now. So what I'm talking about when I talk about that is in the calculator, there is a mode button. And at the top of that mode button, there is normal, scientific, and engineering. Okay? There's also float, and then there's radian and degree. This right here, okay, by default, it should be on, I believe, radian. But I want you guys to have it on degree for right now. I will specify if I ever want you on radian, but you will not need it on radian. And the reason for that is because reality is you won't touch radians until you get the pre-calc. So just put it on degrees. Mode button is right below window, right here. Yep. And then just hit enter, and boom, now your calculator's in degree mode. The reason why is because all the numbers we're plugging in are in degree.